All right, let's get started. So today is WebSocket examples. So just as a reminder, I've covered everything that you need up through Objective 4 for Homework 3. So Homework 3, the content, I mentioned this last time, but just to make sure, the content itself, like the fundamental technical content, it goes pretty quick in the slides. It takes a while for it to seep in and understand. That's why I have a day of examples. But I did cover everything that you need through Objective 4. It goes pretty quick for Homework 3. And then coding it takes a bit. It takes some effort. So I get it all out there, and then you get tons of time. You get like the full homework time to do the bulk of things. And then Objective 5, it takes a lot of lecture time, but once you actually code this up, it's not too much. If your WebSockets are working really well, this is almost trivial to do Objective 5. It's kind of just like a neat cherry on top. Like it's a cool thing that you can do once you have all the knowledge that you currently have, which is, oh, it's right on screen, but it's to make peer-to-peer video chat, which I think is pretty damn cool. The server facilitates the initial connection, and then after that, it's strictly peer-to-peer. Your server kind of steps away and says, I don't need to do anything anymore, and it's a peer-to-peer video chat connection that you do for Objective 5. And most of it's set up in the front end. In my front end code, it does all the stuff to be able to do that. And then in your back end, it's almost nothing that you have to do. You just use your WebSockets to forward messages between the clients to establish that connection. So most of the homework you can do right now. You have the knowledge too. But especially as like office hours indicate, it's tough to know where to start and where to apply everything we learned in the last two lectures. So that's where I want to make things a bit more clear of what you actually need to do in this lecture. And I think, I was going to start here, but I think I'm going to start over in Visual Studio Code. So I want to talk about a few things, because this one's a little bit quicker to explain. Don't need that. Servers, Python. Okay, so I have this server 3. Which I want to talk about how to set up these WebSocket connections and kind of what happens once you do that handshake. And by the way, with all of these interactive, like demo-filled lectures, please let me know the questions. If there's a question that you have, like my whole purpose of doing this, like I don't have to do this at all. My whole purpose of doing this is to help you get rolling with the homework. So if there's something, for those of you who did start Homework 3, or those of you who are starting to think about it, if there's something that's in your way that's a roadblock, or if there's something in my explanation that doesn't make sense, please ask questions, or else there's not a reason for me. If what I do here is confusing, there's no reason for me to do it. This is only strictly to help you. I already covered the content, the concepts, and everything that I need to cover. I want to do this to help eliminate the common mistakes that I see on this homework over the years. So if there's another mistake, or not, I shouldn't say mistake, but misconception, maybe that's the right word, I want to handle that. So, speaking of handle, what happens when you send that first response? You have this handshake, you get a request. That request is to upgrade a TCP connection to a WebSocket connection. You send this response, you read the key header, you compute the accept, you do SHA-1, you do base64 encoding, and you send that back. You send that response, that HTTP response with the 101, and then what? Yes.
Is it a quick question on the WebSocket connection? Does it handle things like image calling? Like if it's asking for a request like loading an image on a new page, will it take that from the WebSocket or will it make a separate TCP?
It would make a separate TCP connection for that HTTP request. Okay. You can use WebSockets to communicate images, but that's up to you to write that code. Like if a developer writes code to communicate images over WebSockets, then yeah. But like if you have an image tag with a URL, it's going to create a new TCP connection, make the HTTP request. Because your TCP connection that's a WebSocket connection, you're only handling WebSocket frames. So if somebody sends an HTTP request over that socket, it's going to jam you all up. You're going to have all kinds of errors in your code. The connection is going to break.
So we run the WebSocket at the same time as making TCP connections possible?
Yes.
Or HTTP?
Yeah. So we get, and I know some of you are going to do this anyway, but I'm going to say it. Don't use this code directly. It's purposely written to have a lot of the good bits removed. I just want to show you the structure of what you should do here. So I'm going to receive a message, and I'm just going to send hello back to this client. This isn't what you would do here, so don't do this. Don't send a generic response. And I'm going to assume, okay, if this was an upgrade request and we upgraded to WebSockets, that means that this reference to a TCP socket connection, which we have in self, you probably haven't thought about this much, but self.request, like you're accessing that socket, a reference to that socket connection. And then you're accessing the response, the request, and then calling receive to get the bytes, to read bytes from that socket. And then we also use request.sendAll to send a response over that socket. But if we have a reference to that socket, we can perform these actions. We can read from it and we can write to it. So you can pass self to another method where that method is expecting a socket, and then do socket.request. You don't always have to go self. You can pass that reference around your code at your leisure. That might be helpful for homework 3. That might be helpful. So the use case for that, I'll get back to where I was saying here in a second, but I want to make sure I set this up like this just so I can talk about this. I want to make sure everybody has this understanding. So when you have WebSocket connections, you could have, like when the TAs test your code, they might have 3 or 4 connections open, all communicating with your server. And when one of those connections sends a message to the chat, that message has to be sent to all 4 clients. So somewhere you're going to need a data structure with references to all 4 of those sockets. So you have a reference to the sockets here, and when you upgrade to a WebSocket connection, you want to take this reference here and store it somewhere where every client connection has access to it, so you can broadcast messages to all connected clients. So you want some variable that all of your clients have access to that's going to store all of those connections. Because when somebody sends a chat, you're going to have to go through all these sockets. You have something that's storing all these sockets and say .request.sendAll, the WebSocket frame that you constructed. So just know that self is a reference to that socket, and you can use that to, well, technically it's a reference to the handler, but you can use that .request to send messages over that connection. You don't have to do that directly from the handle method itself. So I just want to make sure that one's clear. Then you can remember references from 116, and hopefully you remember how that works, and store those in a data structure and all that. Okay, so we get this request. I'm just responding with hello because I'm just simulating things and showing you structure. But if this was an upgrade request, we're going to compute the accept. We're going to respond with our 101, and we're saying this is a WebSocket connection now. So we've did the 3-way TCP handshake, created a TCP connection. I read information from that connection. The client sent me the upgrade request. Over that TCP connection, I sent a response, which is, hey, yeah, this is a WebSocket connection now. And then that TCP connection that we have access to, that we used right here, we're reading from this TCP socket. We're going to leave that open and use that as our WebSocket connection. It's still just a TCP connection, but we're going to expect WebSocket frames over it, and we're going to send WebSocket frames over it. That's all we're going to communicate over this socket after we send the 101 response. So we should have something that looks like this. This is the general structure that you should have, is you don't want to close that connection which the connection will close when you reach the end of the handle method, at least in Python. I'll jump to JavaScript quickly after this. Not very many of you are using JavaScript, but I want to at least show how that works, because it is generally interesting as well. Bless you. But we don't want to hit the end of this method. So what I'm going to do is just write a forever loop, well true. And I'm going to keep reading WebSocket frames inside this loop. Because I don't want to reach the end of this method. If I don't want to reach the end of a method, I'm just going to loop forever. Why not, right? So I'm going to hit this well true, and I'm going to keep reading from the socket, and I'm going to expect this data to be in the format of a WebSocket frame, which it should be. We did the WebSocket handshake. We did that dance with the browser. The browser should only be sending WebSocket frames over this socket, over this TCP connection. So whenever I receive data here, I expect this to be a WebSocket frame. I'm going to go into my parsing. I'm going to read the opcode, the payload length, all that stuff. I'm going to do all that good parsing stuff that we talked about on Wednesday, and then demask the message and read that message. If the payload length is very large, I'm going to enter a buffering state here, just like we did for homework 2. I'm going to enter a buffering state and get all of the WebSocket frame before handling that message, and then handle that message. And when I'm done handling it, I'm going back to the top of this well true, going back for another WebSocket frame, and I'm also going to send messages over this connection that are going to be WebSocket frames. Again, don't use this code because I'm not doing the right thing here. I'm just going to send hello as an HTTP response again, just for this code, just because I don't want the browser to hang. But I'm going to send just hello, but this is where I would be sending WebSocket frames. Yes?
When you want to close the WebSocket, don't you have to send a different request? Like, do we have to code that in as well?
Yes. Oh, yeah. Actually, I do want to show that right now. So if I'm going to have some conditional here. If the opcode is, I'll let you actually figure out how to do it the right way because that's binary and I have it as a string. So break out of the loop, and then that'll close the connection. So if they send us a close, that's the only time we're breaking out of this loop and ending that connection.
Yeah, another thing, do we have to worry about receiving multiple frames in the same receive call? Is that like matter at all?
Yes, that is one of the, in Objective 3, that can happen. So when you receive right here, you might get multiple frames when you call receive. So for example, if the client sends 2 WebSocket frames nearly simultaneously, when you read from the TCP socket, you might get both frames. Or you might get one whole frame and part of the next one. So when you're parsing your payload length and reading bytes from the payload, you have to be mindful of that and make sure you don't read too many bytes because you might be reading the headers of the next message. Where that comes in the code for homework 3 is in Objective 5. Doing the WebRTC stuff, the client will send messages very quickly when it's establishing that connection. So that's why I say homework 5 is nearly trivial as long as you have solid, robust WebSocket code. That's one of the things that can catch up to you on Objective 5. So a heads up to everyone for that one. Okay, so let's run this thing. And go to my code. Send 3 requests. Oh, code not defined. Then I got to change my port because I don't feel like waiting. But there's a problem here. If I can get it all set up. Because I did 2 instead of 3. So I'm going to send a few requests. thought I did restart it. Opcode, opcode. 2 equal signs. I'm just getting rid of this. Let's see if 8,000's ready again. Okay, now I'm going to send 3 requests. Let's send 4 for good measure. Going back to Visual Studio Code. And I'm getting the client, which the client's going to be, the host will be localhost, of course. But I'm reading this client address 0. This is going to be the host. That's localhost 127.0.0.1. But the second value in this client address list is going to be the port. That's the one I want to focus on because I'm always going to have localhost as the host. But the port is going to be important here. And the port is going to be the same each time. So I got a request. I responded to it. I entered this well true. I read a request, responded to it, printed some things out, responded to it, read a request, printed some things out, responded to it. And it's the same connection every time. It's not just reusing the same port. This will actually be the same connection because I left the TCP connection alive. And the browser's, it's got enough optimized code that it says, oh, this TCP connection is still alive. I'm going to reuse that for subsequent HTTP requests. This is something we could have been doing all along. It is more efficient. It's more optimal. But we usually don't worry about it in this class just because it's one extra thing that we'd have to think about. Maybe someday I'll make students do it, but I didn't make you do it. But we can leave that connection alive and handle multiple requests over the same TCP connection like this. There's a big problem. What's the problem here? I'm in this infinite loop handling requests on a single TCP connection. What's the problem? Yeah?
There's no proper way of ending that connection from the server side.
Yeah, there's not. But there's another problem too. Yeah, there's other problems as well. What's one of the problems? You can only have one user. I go to the site in another browser. It's going to try to establish a TCP connection. But guess what my entire server is doing? It's just sitting there waiting for requests from this one person, this one client. That's not good. Now, I kind of pulled a fast one here. It did change the code here. That's why I highlighted this. And I just have TCP server. If you have TCP server right here in your code, you're wrong. Don't do it. Do not do it. You're just asking for trouble. If you did this, that's fine up until homework 3. In homework 3, this will catch up to you, and it just will not work. You will not get your WebSocket connections working because this is your entire server. It is single-threaded. It handles that request. Once it closes, you're open for another connection. You can handle one connection at a time. Luckily, Python has a really easy way to get rid of this, which most of you probably have in your code already because you probably just saw it in lecture and wrote and typed it up. But if I do threading TCP server here, one change, I should have stopped my thing earlier. Threading TCP server, now my server is magically multi-threaded, and I can handle multiple connections simultaneously. Each time I call handle, it's going to happen on a separate thread, and I'll be able to communicate. I'll be able to have multiple connections simultaneously. It just hit me. So people having that issue of global variables being different in different parts of your code. It's probably because it's separate threads. That's probably what's happening. It has got to have something related to that at least. Let's go back to 8002. Oh, I had missed my R. Thank you. Already in use. So let's go to 8002. Let's go to Chrome. Change this to 8002. And I can have multiple connections. So when you have your WebSocket connections open, those connections will be in a loop like this, and you need that thread to be always focused on that client, or not necessarily threads, but focused on that client, but you need to be able to be doing other things simultaneously. So you need concurrency in your code. We have to have concurrency in our code when we're going to have concurrent, persistent connections like this. It's not as important with HTTP. Of course, once you have a good user base, you definitely want that in HTTP as well, but you got away with it until this point in the semester. But now we absolutely need multi-threading because we have multiple persistent connections. If we look at our, just for completeness, it looks like Chrome got 5266. We scroll up enough, we'll see a different number, 5264. Looks like what Opera got. So we got 2 different connections open simultaneously. It won't scale. This won't scale very well. And without threading, it won't scale at all. This won't scale super well, though, because it's pretty expensive. Each connection requires its own thread, which is pretty expensive. So I promised a little bit of JavaScript today. I'm not going to run this, but I want to talk about it at least. With JavaScript and with several other languages have the same architecture, we're going to create the server. I want to be down the line. Whenever we get data on any socket, this method is going to be called. This function, whatever function you give as the callback here, is going to be called with a reference to the socket that where you received the data. Oh, what am I saying? You get a reference from the socket on create server, and then a reference to the data when it's sent. But the socket contains all your information about that specific connection, and then data is the actual data that was read. The same as calling .receive in Python. So here, when you upgrade a connection to a WebSocket connection, you want to keep track of their ID, most importantly their port number. But both, just port number is going to get you through testing because it's always localhost. But you don't want 2 clients with the same port and different IPs being treated as the same client either out there in production. So you want to make sure you have some way of uniquely identifying a client. And then when a client is upgraded to a WebSocket connection, check, is this, add them to some data structure and say, here are all my WebSocket connections. And then check when you get a message, say, is this client a WebSocket connection? Is this host and port, which is unique, is this a WebSocket connection? If it is, handle it as a frame. If it's not, handle it as an HTTP request. So things are a little bit different. You don't have your while true in JavaScript if you're using this. So you got to handle that a different way. It's by keeping track of your clients that are WebSockets. Or just store a reference to the socket and say, is this socket in my WebSocket connections list? Array in JavaScript. JavaScript, incidentally, this will scale a lot better. JavaScript does not use a separate thread for every connection. It'll use I forget the term, but it's like a lightweight form of threads where you have a thread pool and then you go through that. You have a manager that's handling all the connections, and then whenever a connection needs attention, it gets one of the threads in the thread pool. It's much more efficient, especially when you have a lot of downtime. Like these WebSockets, most of the time, they're going to be just sitting there doing nothing. By that I mean when you get a message and you're sending responses, like that's going to happen in like millisecond time frame. And then you might have 100 milliseconds where it's doing nothing, and then a millisecond where you get a message and you respond. Most of the time, it's sitting there doing nothing, even if you're actively using the connection. A lot of time, it's just sleeping. So this would highly optimize your resource usage over using threads, which would need dedicated resources, even if the thread is sleeping. JavaScript greater than Python. Well, with Python, you can import a library and do the same thing. But the default kind of easiest way to do TCP in each languages, JavaScript is more efficient. But you can do the same thing in Python. You just got to do a little more work. Or not even more work. You just got to find an external library that does that. Or actually, for what I... I guess I never really looked into it too hard. There might be just another magic word we could put here. I don't know. I haven't looked too that far into the TCP, into the optimization side of the TCP libraries in Python. All right, let's kill this and go on to the next thing. So here we have some other code. This is more implemented, so I got to be careful not to show too much code. But I will show you a decent amount. I got my note in here that says, Jesse, don't go higher than this during lecture, because that's where all my WebSocket solution stuff is. But we'll show a little bit of this. So, I want to talk about testing. I talked about it a little bit on Monday, and I'm going to strongly recommend that you do some formal testing when working with WebSockets. Some of you will choose to, and you can get away with just testing by opening your browser, running your server, opening your browser, and seeing if the chat feature works. Some of you will even get away with that, but I'll strongly recommend doing some actual testing, because unless you're just a miracle worker and you just code it all perfect the first time and everything's great, unless you're able to do that, you're going to save a ton of time by actually writing tests. This is one case where even writing my solution code, I wrote tests for this. I'm going to show you those tests right here. I wrote tests for this. You don't have to have anything formal or anything too outrageous, but having something to be able to test this will save you tons of time. Instead of, especially if you're using Docker all the time, spinning up your app in Docker and then going to the browser and then saying it doesn't work and getting no clue as to why it doesn't work is... that's just asking for hours and hours and days, maybe even weeks of debugging to be able to fix your issues, where you could just write a couple simple tests and find your issues like that. I found a really, in my unit test, I found a bug that would have taken me at least a few hours to debug if I didn't have a unit test. I'll talk about that right now. First, a nice helper method here. Let me run this main first. I put this import down here because I have to comment it out to run my main. But I have the data ABC, and I'm going to iterate over that data. This is as bytes, so this is how you're going to receive data over the connection. I'm just going to print out the byte. I'm going to print out the byte as binary. I'm going to print out the byte as binary after removing the first two characters, and then I'm going to call this function byte to binary string. And I'll show you the difference of each of them. So here's just printing out the byte. It's going to give me the numeric value of that byte. In this case, it's the ASCII character A, which is going to have the value 97 in decimal. So this is showing what I said in the previous lectures. These bytes are just integer values. I can add 1 to A, and I'll end up with B. These are integer values. Let's prove that, actually. Let's not prove that, because I don't know what just happened. It added that to all three of them. I don't want to think about what... because I added it in here, yeah. So instead of 97, 98, 99, it showed me 98, 99, 100. Because I added it in the loop. I added it to each one of those. So it just gave me different ASCII values. So printing it gives me the numeric value. If I call bin of that, that's going to convert it to binary and then print out that binary string, which starts with 0b, which is just like our /x up here. It's saying this is in binary, so we don't confuse it as a decimal number or a hex value. So in the next line, I'm doing the same thing, except I'm removing the first two characters, so I don't have to look at that 0b. I'm getting the same exact bits, but I don't have to look at that 0b. And then finally, I'm calling byte to binary string, which is a method I wrote. So I recommend you do the same thing. Just take my code if you want. But I've shown this a few times in office hours, so to be fair, I got to show it to everyone. I'm going to do the same thing, convert the byte to binary, convert it to a string, remove the first two characters, but what happens when you print it out like this is you lose your leading zeros, it truncates your leading zeros and just doesn't show them. But when I'm printing out, and what we're building up to is printing out the WebSocket frames, by the way. I want to print them out in a nice, clean fashion. So when I'm printing out my WebSocket frames, I want these leading zeros. So I wrote this stupid loop that's going to loop from the length of that string to 8, and then prepend 0 for each one. If you want to write better code, go for it. I just wrote the stupidest thing that came into my head first and just did that. It works well, it's robust, but you could get it done in less code easily. It's a decent amount of code for doing something so trivial. And then I'm returning that. So now I have that printed out with the leading zeros. And that's how I want my bytes to show up. So for each byte, when I read from a WebSocket frame, I'm going to print out each byte as binary with the leading zeros. And further, I'm not going to show this code, but I'm going to print those in chunks of 4 per line, so it matches with how I'm used to looking at the protocol, how I'm used to looking at that chart. Obviously you can write that line. You loop through them, you have a counter that counts up to 4, and if it's 4, you add a new line. You can all handle that. I just don't know where that code is right now, so it's up in the danger zone, so I'm not going to show it. All right. And then my tests. So I talked about the key and accept last time. I went to a website, I grabbed these values. I know what I have as my key. I know what I expect as my accept because I just went to a website and grabbed a key and accept. I'm going to call my compute accept method with the key. And then Python has this assert keyword. I'm just going to assert that my accept that I computed was equal to the accept that I expected. And if it isn't, I'm going to print them both to the screen. Easy day. You should have a test like this, or exactly this test. I'd recommend getting the practice of going to the console and grabbing your own key and accept. But if you want to type these, I ain't stopping you. I can't stop you. This helped me find a bug that would have taken me forever. So my accept and expected accept looked identical. And it wasn't passing this test. It would say assert failed, accept did not equal expected accept, and they were the same string. Except the one I computed had a new line character at the end of it. That would have taken me forever to look through my debugger console in my browser and find this invisible character that doesn't show up anywhere. But when I printed it like this, there was just a /n at the end. Easy day. I looked at my test, I'm like, oh yeah, I better trim that up. It was the library I was using had a few method calls. One would take multiple lines of values in base64 encode them, and another method to take a single value in base64 encode it. I was calling the one that took multiple lines, so it said, okay, the first line is this, let's go on to the next line, and oh, there's nothing else there. So I was adding that new line character. Some of you might find that same method. If you run into that same bug and you come to my office hours, I'm going to say, you didn't go to lecture, you didn't pay attention. So actually no, I wouldn't say that. I would say, where's your unit test? And then go from there. Because if you write a unit test, if you write a test like this, and we're not even using a formal unit testing framework, just use this assert keyword. Like, you don't have to get super fancy like we did in 1.16, but have some way of testing. Have some tests. Because that saved me, this test right here saved me hours. Finding that white space character would have taken me so long. And it wasn't a /r/n, so the browser wouldn't have interpreted it as anything meaningful. It was just a /n. Like, it would have taken me forever. Yeah?
I hope we're going to use libraries.
For what? For what parts, you mean?
For the homework.
For the helper?
Yeah, the homework.
For the homework. Yeah, I mean, depends what libraries you're talking about. For SHA-1 and base64 encoding, yes. I don't expect you to implement SHA-1 or base64. Those should just be method calls of libraries. For most of the rest of this is... So the general rule of thumb, let me give that a better answer. The general rule of thumb is if I go into detail about how to do it in lecture, you have to go into detail about how to do it in your code. If I don't go into detail in lecture, like I didn't have slides on this is how you compute SHA-1, this is how you compute base64 encoding, it's safe to assume that you can use libraries for that. I didn't explain how to take 8 an array of 8 bytes and convert it to one integer. So if you find a library that does that for you, knock yourself out. Go for it. Because I didn't explain how to do that. But like I explained how to parse the payload length. So if you find a library that takes a WebSocket frame and spits out the payload length, then you're definitely wrong. That's no good. Same with JSON, since it's on the screen right now. Use libraries for your JSON parsing and building your JSON strings. Knock yourself out with that one. I never went into here's the JSON format, here's where you put your quotes and everything. Use libraries for that. Okay. Before I talk about the test frame parsing, I want to do something else. I'm going to comment this out. Oh, by the way, I'm running both of those, and we don't see any output because the test passed. Yay. That's the nice thing about unit testing, as opposed to like just printing a bunch of crap to the screen like I did here, is the unit testing only shows you the output of the failing tests. You all know this from 116. I don't got to talk about that again. But let's run the server. Port 8001. To actually do this the right way. 8001/webrtc. And we should see that show up immediately. This is the benefit of WebSockets. Shows up immediately in both browsers. That's what we want. That's what WebSockets do for us. So our chat works. What I want to do is go into PyCharm and look at all this stuff. I'm printing out a whole bunch of stuff when I'm sending these frames. So let's take a look at it. First, I'm printing out the entire frame in hex. I'm just printing the frame. I'm reading from the TCP connection and printing that whole thing out as a byte string. Not parsing anything, just printing it out. This is what I'm using. Oh, I'm in server. This is what I'm using in my web frame parsing test. I printed that out. Once I have my handshake working well and I can send WebSocket frames to my server, I print out one of those frames, I copy it, I go into my test, I paste it. I know exactly what that frame should be because I know exactly what message I sent to the server. And then I make sure, have all my asserts to make sure that I actually got that message. So I typed, I'm testing with a login message, which we don't do anymore. But I knew this was the content of my message. I know what the payload length should be from that. I call my parsing code, and I make sure that I get the right payload length, and I make sure that I get the right payload. If I get those two values, I'm going to assume that I did everything else pretty okay. So I have a test to make sure that I'm doing all that right. I changed some code. I hit a button, run this test again, see what it says. I changed my code. I hit this button. Very, very fast debug cycles. Very, very fast. That's what we want from unit testing. One of the things we want from unit testing. And then let's look at this frame itself. So we can see the bytes. I'm iterating through these one at a time and printing out the bytes the same way I did right here. I'm just doing byte to binary string, except I'm adding a line break every 4 bytes. So I can have this in the format that I'm used to seeing. And we can see what these bytes are. We can see the first byte is 1, or the first bit is 1. That's my fin bit. I expect that to be 1. Since this is a pretty small message, I'm only going to have 1 frame for this entire message. If this were 0, I would expect multiple frames for that same message. My reserve bits are 0, 0, 0, which we can assume they'll always be for this homework. My op code is 0, 0, 0, 1. So that means that this is the content of this is text. My mask bit is 1. That means this will be masked data. And my payload length, I can tell that this isn't 126 or 127. So this is my payload length. And it's going to be, let's see, 2, 6, 32. No, is that right? I'm going to cheat. 54. Hey, look, I can do math. So that's going to be 54 in binary. I know since those 7 bits had to be my entire payload length, that these 4 bytes are my mask, the masking key, and then this is my payload, 54 bytes of payload, which are all masked by that masking key. And I'll do what time is it? I'll do 1 byte. So I expect the payload is going to start with an open brace. So I'll do just the first byte. I'm going to mask this with this. So I'm going to get 1, 1, 1, 1, 0, 1, 1 after masking this. XORed with these, so the last 2 bits will flip when I XOR it with the first byte of the key. And if I find an ASCII chart real quick, that should be open brace. It will be open brace. There's no way it will not be. Oh, come on. Oh, this isn't, what am I doing? Let me go to that first one I saw. Let's do it this way. 1, 1, 1, 1, 0, 1, 1. Convert, and we get our open brace. So we're going to demask each byte of the content to get our actual content. And once we decode everything, this byte XORed with this byte XORed with this byte, this byte XORed with this byte XORed with this byte XORed with this byte we start over at the beginning of the mask, etc. This byte start at the beginning of the mask again. This byte XORed with the beginning of the mask. This byte XORed with the second byte of the mask. And then we're done. That's the end of the content. So once we demask everything, we find out that this is the payload. We're going to add the username to that. The random usernames are generated server side for this. And then send this message back. Then we can see all of our frames here in that format. Which I got through everything I wanted to make sure. Oh, no, that I didn't get through everything. I want to do one more thing. But let me catch up on chat. Oh, there's. TypeScript is pretty good. There's one more thing I want to do. Oh, God damn it. No, here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to copy this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 100 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10,000. Let's not tempt fate too much. And we should have, I'm confident in my code, but everything can go wrong with demos. So we get our 7-bit payload length, which is going to be 126. And then this is going to be my actual payload length. If I convert this value into decimal, it should be 10,050 or so, because there's some extra overhead from the JSON formatting. If we scroll all the way down here, we'll see 10,050 or so. 10,042 is our payload length. So that's our payload length not fitting in 7 bits. So we needed those extra 2 bytes to represent the payload length. And then same thing, if I went over 65,000, I would have to change that again. I would see a 127 and then the value. So that's how I recommend testing that. I like doing the 1 through 0 and then cut and pasting a bunch of times to get that. Yeah, it is kind of quiet. Any questions? So hopefully that helps you on the homework. I know a lot of you haven't started homework 3 yet, but when you do, you can watch this video and say, oh, that's what the hell he meant there. But have a great weekend. I'll see everybody Monday.